We'll proceed in calculation of cross Jacobian. Cross Jacobian in calculus. Many times we have discussed about cross Jacobian in calculus. Cross Jacobian in calculus. Again, I am saying cross Jacobian in calculus. If you are talking about cross Jacobian, what are the other Jacobians? Partial Jacobian and full Jacobian. So there are three kind of Jacobian that we are talking about: full Jacobian, partial Jacobian, and cross Jacobian. What are these? These are different form of Jacobian. Partial Jacobian, if I am doing it like I am calculating volume, we have used partial Jacobian, full Jacobian, and then cross Jacobian in calculation in doing the manipulation with the cone and sphere. We have calculated surface area of the cone through the partial Jacobian and through the cross Jacobian. We have calculated surface area of a sphere through partial Jacobian and full Jacobian. We have calculated volume of a sphere through partial Jacobian and full Jacobian. So now the era has come, the way we did the cross Jacobian in calculation of surface area of a cone. Can we use cross Jacobian to calculate the surface area of a sphere and volume of a sphere? Mind blowing, very interesting. So cross Jacobian. What is cross Jacobian? Jacobian comes into the picture when we go for the integration by substitution. If we go by integration by substitution, then then Jacobian comes into the picture. Like I am trying to calculate volume of a sphere. So volume, if I have a z, so I have I have xy plane. This is xy plane. If this is xy plane, in the way this is xy plane in a way that this is x-axis, this is y-axis, and this is z-axis. X-axis, y-axis, z-axis. Now this is xy plane. This is xz plane. This is yz plane. Now this is x-axis, this is y-axis, and this is z-axis. Z is also called function over x and y. Z equal to fxy, small f, and in bracket x comma y bracket close. Z equal to fxy. This is called function over x and y or z value. Now the volume of a surface, if this is xy plane and I have set up xy point on the display, if I apply function over x and y, it gives the z value, height. Okay, this is one point called x comma y, and its fxy is this point. There is another point called x comma y, fxy is this point. If I start connecting all the points, it becomes a surface. Okay, if this is the surface, what is the volume underneath this surface till it is touching xy plane? Full. If this surface is lying on the xy plane, the volume underneath this surface, this 3D, this is 2D, this is 3D. Whatever the volume under this 3D, or if the surface is at this height, then this volume plus whatever comes underneath it, fxy, then dx dy. This is generally it is found in the book, but actually it is fxy dxy plane. XY plane is considered as independent component. So fxy dxy plane, integration over a limit. So fxy is integrand, dxy plane is differential, and then its limit. Okay, when we talk about the limit, then if we are talking about the volume under this surface, if this is the volume, if this is the surface volume that is coming underneath this, I mean we are talking about the limit. There are three parts in the integration. One is limit, one is integrand, one is differential. Fxy is integrand, dxy plane is the differential, and the limit. Limit is, if I am trying to calculate volume under this surface, then this surface would go and touch the xy plane. Whatever the intersection we are seeing, okay, if this is the case, if I draw a line here, curve here, whatever the intersection we are seeing, that is the limit. That is called region in xy plane. What is the region, closed region on xy plane? That is the limit. Pretty clear? So that is the limit. If it is a sphere, then this intersection would be a circle. Circle with radius a, that is the radius of the sphere. Okay, so I'm going to get a sphere. Sphere. I believe it will be big one. Okay, so I have this big sphere. Okay, so this is a sphere, and this sphere has, if this sphere falls on xy plane, then it will form a circle. Now, idea is, can we find the volume of the sphere through cross Jacobian? Volume of the sphere through cross Jacobian. Now, rather than a sphere sitting on top of xy plane, I consider sphere is pierced. I'm pushing in, and it is centered at the origin. This sphere, this sphere is centered at the origin. This sphere is centered at the origin. Means half of the sphere is below xy plane and half of the sphere is above the xy plane, and it is centered at the origin. What is the volume of the sphere that is under the question mark? If that is the case, then how I can use cross Jacobian? Cross Jacobian is used in vector form. If I try to calculate the volume, we are trying to calculate volume of upper hemisphere. If this sphere is centered at the origin, there is a lower hemisphere, upper hemisphere. We are trying to calculate volume of upper hemisphere. If that is the case, what is the equation of a sphere? X square, y square, z square equal to a square. X square plus y square plus z square equal to a square. If that is the scenario, z equal to square root of a square minus x square minus y square. If that is the case, then now fxy, z, square root of a square minus x square minus y square dx dy, dxy plane dx dy, and limit is a circular region where x is minus a to a and y is minus square root of a square minus x square to plus square root of a square minus x square. If someone can calculate it, then he would calculate the volume of upper hemisphere. If I go with the full Jacobian, then I can consider another coordinate system called theta r. Now I convert xy to theta r. This is full Jacobian, partial Jacobian. Only y we will change it to theta. X would remain as it is, dx dy, only dy. This is partial. What is cross Jacobian? We have demonstrated it, cross Jacobian. Cross Jacobian comes into the picture when the when vector notation comes into the picture. Can we calculate volume of a sphere in density function? Volume of a sphere can be calculated through fxy. Volume of a sphere can be calculated through fxyz. Volume of a sphere can be calculated through density function. Area of a circle can be calculated through volume calculation fxy. Area of a circle can be calculated by simple fx dx. Area of a circle can be calculated in 3 dimension also. Can someone believe it? Through 3 dimension, area of a circle can be calculated. Through 4 dimension, volume of a sphere can be calculated. Fxy dx dy, this is 3D calculation. Fxyz dx dy dz. This way also volume of a sphere can be calculated. This is called 4 dimension, and this is called density calculation. So what is the catch here? Fxyz, the density function is 1. Density of the sphere is 1. Everywhere it is same. If that is the case, we are trying to calculate the net volume, net weight, and net weight is nothing but it will calculate the volume. Volume into density is the weight. If density is 1, then volume into 1 is nothing but volume only, right? Density is nothing but weight per meter cube and volume is meter cube. If I want to calculate the weight of a sphere, then density into the volume. If density is 1, then volume into density is the weight. Same as volume, right? So fxy, these are our way. Okay, it is not available certainly in any of them. Please support us. +91 9483160610. +91 is India country code, and then 9483160610. That is the telephone number. Anyway, now we are trying to calculate the volume of a sphere through cross Jacobian. Now, the volume formula, the density formula of a sphere is 1. Fxyz is 1. 1 dx dy dz. dxyz cuboid. dxyz coordinate system, whatever comes to the mind. Now, integration is not a region on xy plane. It is a three-dimensional region in a xyz cuboid. Okay, where z is minus, sorry, we are talking about xy plane. On top of it hemisphere is there. We are not talking about the lower hemisphere, so we will multiply by 2. So z is 0. Z is 0 to square root of a square minus x square minus y square, where y is from minus a square root of a square minus x square to plus a square root of a square minus x square, and x is from minus a to plus a. 1 dx dy dz. dxyz volume cubic. dxyz volume cubic. Now let's take any point P. Any point P on the 4-dimensional, not 3-dimensional. Any point P in the 4-dimensional cube. If that is the case, the P point is x, y, z, density. dp by dx, dp by dy, dp by dz, dp by dx, dp by dy, dp by dz, dp by dx. What is P? xi plus yj plus zk plus d alpha. Alpha is the fourth component. D is the density. dp by dx, I plus dd by dx alpha. dp by dy, j plus dd by dy alpha. dp by dz, k plus dd by dz alpha. Okay. Now dp by dx cross dp by dy in bracket dot dp by dz. It is also called triple scalar product. Triple scalar product gives the volume dp by dx cross dp by dy dot dp by dz. This is nothing but dxyz volume by, this is nothing but the density volume, the density volume, the density volume by dxyz cubical volume. Very mind blowing, head breaking. So I have now XYZ coordinate system, XYZ cubical coordinate system. Now on top of it, there is a cubical density function. This density function is dependent upon XYZ. Now d density q by d xyz cube means if I make unit change meter cube, that is the volume. If I make unit change in the xyz cube, how many unit change in the density cube it is making? Density cube is dependent upon xyz cube. dp by dz, dp by dx cross dp by dy and then dot dp by dz. So top is d density cube, dp by dx is I plus dd by dx alpha. Means if this is x-axis, consider that density along the x-axis it is changing. Or if I take in height, then this is x, then this is density. Don't get confused with the z-axis, that is different. This is hypothetical, this is abstract, this is something imaginable. Someone can imagine it. If there is a x-axis, then density is growing, decreasing along the x-axis. If that, the density, if I draw in a kind of vertical, then this is x density plane. This is y density plane and this is z density plane. dp by dx, I plus d density by dx alpha. Alpha is the fourth coordinate here. If that is the case, then dp by dx, dp by dy, dp by dz, dp by dx hangs in I and alpha plane. dp by dy hangs in j and alpha plane. dp by dz hangs in k and alpha plane. If that is the scenario, then dp by dx cross dp by dy. If this is xy plane, dp by dx, dp by dx and dp by dy. Okay, so this would point in a some direction. Okay, I believe dp by dx I plus I plus d by dx alpha. In that is the vector region. Similarly, so if I trying to calculate volume, I cannot go for triple cross product. Means simple example, if I cross j gives direction of k, if I do k cross k, it becomes 0. So to get the volume, I cross j and dot with the k. This is called triple scalar product also. That's why we are doing dp by dx cross dp by dy dot dp by dz. That is d density volume by dxyz volume. If that is the scenario, then if I am trying to, what we are trying to calculate, d density volume, where density is 1, net we will get the volume. D density volume, but we are getting dp by ds cross dp by dy dot dp by d density volume by dxyz volume. Down should go away, so we will multiply with the dxyz volume. dxyz cut down and we get the d density volume. This is another way. Okay, if that is the scenario, we are talking about cross Jacobian. Cross Jacobian, now someone can try. No one has stopped anyone. If that is the that is the if no one has stopped anyone, then dp by dx cross dp by dy and then dot dp by dz. Someone can try. Okay, no one is stopping anyone. Okay, this is the way someone can calculate the d volume or whatever it is. Okay, cross Jacobian comes into the picture. Cross Jacobian that comes into the picture when we are we are trying to calculate the volume through different coordinate system. This may be difficult. I don't know how easy and how difficult it is, I don't know. But we are talking about cross Jacobian. Cross Jacobian means if I have XYZ volume, XYZ coordinate system, on top of it, density is dependent upon. XYZ would depend upon some other theta r phi. Okay, now this density would, rather than depending upon xyz should go away and this density directly depend upon the theta r. So the theta r phi calculation is easy. So theta phi calculation is easy. So that is the reason we go for the cross Jacobian. XYZ volume on top of it, then there is a density calculation, and then XYZ is now dependent upon theta r phi. Okay. Now, if that is the scenario, we take out the XYZ and let the density depend directly on the theta r phi. So here we have d density by dxyz into dxyz. dxyz I can rewrite as dxyz by d theta r phi into d theta phi. Now it becomes d density by dxyz into dxyz by d theta r phi into d theta r phi. Xyz cut down. Now it became d density by d theta r phi into d theta r phi. So d theta r phi is not d theta, dr d phi. And what about this? dp by d theta r phi. Okay. Now dp by d theta r phi. Now we have p as d. This is nothing but the way we did dp by d d d density volume by dxyz by dp by dx cross dp by dy dot dp by dz. Now here it will come as now dp by d theta cross dp by dp by d theta cross dp by dr and dot dp by d phi. What is p that we will see now? Okay, so p I can take as xi plus yj plus zk. P is xi plus xi plus yz xi plus y I'm sorry, xi plus yj plus zk plus density alpha. So density is 1, its derivation with theta or whatever, it will be 0. Now we can take xi plus yj plus zk by d theta cross xi plus yj plus zk by d r and cross dot d xi plus yj plus zk by d phi into d theta d phi dr. Okay, if that is the scenario, then how we can proceed again? X dp by dx. I'm sorry, dp by earlier it was dp by dx. Now it is d density xy d density by d theta r phi into d theta r phi. Okay. Now dp by d theta cross dp by dr bracket close dot dp by d phi. Now dp by d theta. What is P? Xi plus Yj plus Zk plus density alpha. Density alpha we can take out because all the derivation will go. X is in a spherical coordinate system. If you are talking about r theta, I am getting sweating badly. This is very difficult. This is what we can do. This is the most advanced calculus, that is the Jacobian. This is cross Jacobian we are talking about. If I have if I have something to do in XYZ, can I transfer this load to r theta r phi? Now dp by d theta cross dp by dr bracket close dot dp by dp by dp by d phi, and then d theta dr d phi. This would become a where p is xi plus yj plus zk. By d theta, if I start doing, it will become a matrix determinant where top is dp by d d dp. Top is dp by d theta, dp by d r, dp by d phi, dx by d theta I, dx dy by d theta j, dz by d theta k. Next, dx by dr, dx by dy by dr, dy by d phi k. Next is dx by d phi I, dx by dy by d phi j, dz by d phi k. Now this is the kind of determinant I have to find out. Or someone can use it as dx by d theta, dx by dr, dx by d phi. Next row, dy by d theta, dy by dr, dy by d phi, dy by d theta, dy by dz by d theta, dz by dr, dz by d phi. This Jacobian. Now everyone knows that someone really try to calculate it, the Jacobian of the this becomes a Jacobian of a spherical coordinate system, and that results in I believe that would be kind of a square, that is the radius of the sphere, a a a square. Okay, I mean r square. That x is x is r sine x is a sine phi, x is a sine phi, x is a sine phi, or okay, x is a sine phi cos theta I, y is a sine phi sine theta j, and z is, we are talking about volume, so we cannot take. Now if this is the sphere, very difficult. If this is the sphere and I talk about any volume inside this sphere, small volume, that small volume is at radius r, okay, r, variable r, then the x is, and make phi angle from the vertical, then x is r sine phi cos theta I, y is r, where the radius of this sphere is a. So x is r cos phi, r sine phi I, y is r sine phi j, r sine phi sine theta j, and then z is r cos phi k. Now someone can settle it down. It becomes r square sine phi, the Jacobian. R square sine phi. R square sine phi d theta dr d phi. Now we have to settle down all three, the kind of limit. So z is 0 to square root of a square minus x square minus y square. So that is the z, and then y is minus square root of a square minus x square to square root of a square minus x square. X is minus a to a. Okay, so we will try now. Now it is the height, that is z. Height is z. Z equal to r cos phi. z equal to here 0 to square root of a square minus x square minus y square. Here z equal to r cos phi. R cos phi equal to square root of a square minus r sin phi cos theta whole square minus r sin phi. I believe I can do settle better way. Z equal to square root of a square minus x square minus y square. Then z square equal to a square minus x square minus y square. X square plus y square plus z square equal to a square. Then r z is r square cos square phi, where it is r square sin square phi cos square theta, and then r square sin square phi sin square theta. If I settle down the x and y, it becomes r square sin square phi, and here r square cos square phi, r square. R square equal to a square, r is a. So first radius would settle down 0 to a, 0 to a. Now y is minus a square root of a square minus x square to a square root of a square minus x square. Let's consider y is 0 to a square root of a square minus x square. If I am trying to calculate the upper hemisphere volume, the volume upper hemisphere through cross Jacobian, in upper hemisphere I try upper circle. The limit region is upper circle, not the below circle. So 1/4 volume we are trying now. 0 to y is 0 to square root of a square minus x square. Now y equal to a, then it becomes x square plus a, y equal to square root of a square minus x square plus y square equal to a square. Y is r square, y. Now we are trying to calculate the kind of I believe phi. Okay, so now once this radius calculation is done, then we can now consider y. The y region here, the y region radius is a. Y region radius, when we are talking about r limit, r is variable from 0 to a. Now when we are talking the calculation of the y, that is phi angle y on the xy plane, the radius is full a. In that sense, x square plus y square, x is a sin phi cos theta, y sin phi sin theta. A square cos sin square phi will become cos square theta plus a square sin square phi sin square theta equal to a square. Okay, if that is the case, then a square gone. Cos square theta sin square theta become 1. Sin square phi equal to 1. Then phi equal to pi by 2. So 0 to pi by 2. Phi is going 0 to pi by 2. R is going 0 to a. Now what about theta, where x is minus a to a? Okay, if that is the scenario, x is minus a to a, then it is, we have already talked, x equal to a cos phi, a cos a sin phi cos theta, y is a sin phi sin theta. If I divide, then tan theta equal to y by x, theta equal to tan inverse y by x. When x is a, y is 0, then tan inverse x is minus a, y is 0, and x is minus a. Tan inverse minus 0, pi, and other is 0, pi to 0. Now theta is pi to 0, not 2 pi, pi to 0. Phi is 0 to pi by 2, and radius is 0 to a. Okay, now r square sin phi dr d theta d phi. R square, if I integrate, it becomes r to the power 3 by 3. Limit 0 to a to the power 3 by 3. A to the power 3 by 3 I can keep outside. Now sin phi d phi minus cos phi, minus cos phi, minus cos phi, limit 0 to pi by 2. So pi by 2 cos is 0, 0, negative limit 1, minus, so it becomes I believe minus minus cut down 1. Only a by 3 is still it is remaining. That's it. Now theta. Theta integration is pi. Theta integration d theta is theta. Pi to 0. I believe negative positive is some confusion. No, it is pi a to the power 3 by 3. This is the volume of the quarter hemisphere and then again half of it. So net volume of the sphere through cross Jacobian is 4 pi by 3. I am sorry, pi a to the power 3 by 3. 4 pi a to the power 3 by 3. 4 pi a to the power 3 by 3. Okay, if it is kind of very difficult, then better would be someone can take pen and paper and try there. Okay, someone can take pen and paper and try there. So try with the cross Jacobian calculating the surface of cone. This is what we have already done. In next session we will do cross Jacobian calculating the surface area of the sphere. We have used cross Jacobian to calculate the surface area of a cone. That video someone can watch. And analogous to it, only we have tried calculating the volume of a sphere through cross Jacobian. In cross Jacobian, full r theta, full r, full r theta phi, r theta phi. Triple integration comes into the picture with the cross Jacobian as far as calculation of volume is concerned. We will see cross Jacobian while calculating the surface area of a sphere. But using cross Jacobian to calculate the volume of a sphere, we can calculate volume of a sphere through partial Jacobian. Very easy. Full Jacobian, even easy. This is also easy, but it uses density function because cross Jacobian uses vector form. In that form, cross Jacobian dp by dx cross dp by dy dot dp by dz or in cross Jacobian dp by d theta cross dp by dr dot dp by d phi. This is what we are using. So we will proceed on it. Please support us plus 919483160610 plus 91 is the India country code. This is how we will proceed.